Yeah, so this is the front page of Copernicus Dataspace Ecosystem. This is where you would register. I'm already registered and logged in. This is where you start with the Copernicus browser. And that's all the information about the services and our newsletter and our roadmap. Any news on the data space is typically here. And we also have a gallery with pretty images. So I can really recommend taking a look at this or following us on LinkedIn, because we also post our gallery features there. But over to the browser now. Oh yes, if you're logging into the browser for the first time, there's a small click-through tutorial that will show you the main functions. So what you have here is Sentinel-2 Mosaic of Europe from April 2024. And on the right-hand panels, you have different small analysis functions. And the left-hand panel is the one that you use for actually controlling what you see. First of all, this is where you can set the language. We are going to use the English settings throughout the browser, but don't hesitate to change it to your local language, especially if you're using it for teaching or whatever. If your language is not there, but you're interested to contribute, we have a really nice system for translation. So it's pretty easy to translate all the words and the paragraphs that we use. And we are always really, really looking forward to contributions from other people to release new languages. But first of all, let us click away this panel for a moment. So we can look at large-scale biome patterns. Here we have the deserts, green areas. You can see how the density of vegetation changes across Europe. You can see the mountain ranges. This is the generic pattern that you can see with the seamless Sentinel-2 Mosaic. If you just click on, well, first of all, let's go for Sentinel-2 Mosaic, so the data collection. And then you can just click show latest data, and then it's using the latest mosaic. And the first thing I want to show is sharing a location. So if you just go here on share and you click generate, you're getting a short URL, and anybody who puts this URL in their browser is taken directly to Copernicus Browser, and they're going to see the same place and the same visualization. So this is how I generated the links that I have in the chat and the ones that I want to show you here. The satellite image is going to load in a second. This is again a Sentinel-2 Mosaic. This is normally a rather cloudy place, so not so easy to get a cloud-free image. And the question or the challenge is to estimate the scale of these patterns. So what's the typical size of the lakes you get here? Can you give me a guess in meters or kilometers? 10, 15 kilometers?
What is the is Sentinel-2 image?
This is Sentinel-2 image. Okay, you actually have the scale bar down here, so it's not a very difficult question. But the function I want you to test is just measuring distances. So you can measure distances with this little tool. You can also measure areas. And then this is what you use just for very rough quantitative estimate of. If you click twice on a corner, then it releases. This is the tool we use for downloading images. So basic downloads are a couple of hundred pixels. Analytical downloads allow you to select the bands that you want to download for your specific view. And then you also have the high-resolution print downloads, where you can actually set the DPI. And high-resolution print and basic allows you to enter a caption. And if you're creating an area of interest, like here, then you can also clip the download to that area of interest. So this place is in northeastern Siberia. And you can see that even on the April mosaic, it's quite snowy. So now we move into a place that should be familiar to you. So I'm going to go to Budapest, but if you have a specific place where you walk around a lot, or where you sort of have a good impression of buildings and on the scale of things, then go ahead and zoom to that place, and we can explore around a bit more. Okay. Steamed is wrong. Sorry from people online. Then we just go to Budapest. Take a look at the latest image. I'm going to post the image in a chat anyway. I mean, the link to the one we're looking at. So normally, if you want to look at a place, then what you do is you select Sentinel-2, and you just hit the big green button. This is giving you the latest image, which is more or less cloud-free. More or less cloud-free is the 30% that you see up there. So if I open up let the image load, but then I can open up the calendar panel. Yes, this is the 9th of November. We are going to explore this image in a lot of detail. This is your cloud threshold, right? And you can set it according to how much cloud cover you are willing to accept. If you can go all the way up to 78%, then, for example, you have an image here which is considered cloud-free. If you only accept 8%, then this is going to be, these two are going to be your only images in the month which are considered cloud-free. This is how you select the images you're looking at. And then if you click on show latest date, it's going to apply this threshold. I'm going to share this pic for the ones online. You can just open it up and start storing. We can make this faster if I close a couple of tabs. Otherwise, this is going to be difficult. Meanwhile, we have this layers tab up here. You can change the base map. So typically you use the Sentinel-2 mosaic as a base map, but it can also be OpenStreetMap or Voyager or like, so other OpenStreetMap derives map products. And you can add some map overlays that will also be displayed on top of the satellite image. Water bodies, elevation contours, roads, borders, and labels. And it's also possible to close the image over here, right? Well, what do we see here? This is a stadium. And you can also see the shadow of it because we are in November and the sun is rather low. Sentinel-2 images, if I'm not mistaken, are typically taken around 10 o'clock local time.
Every 10 o'clock.
Every 10 o'clock at the specific place where it's taken because of the sun synchronous orbit. So it's doing every south-north pass at the local 10 o'clock time.
That's it. It's 8 hours. This far past 9. Good. 24 hours. Every 16 days. 14 days, maybe. Something like that. So the trick is with the sun synchronous orbits that this 10 o'clock what Andreas mentioned is a local time. It's not the time zone time, but this is the local astronomical time.
I was curious to know how the Earth company, especially in the land, they have an application which is linked with the immense satellite, and they are monitoring the health of the plant health. So that the farmer can they have an application, the farmers can check the farm every day. So we can take the image whichever posing there is when one.
The point is that integrating images from different sources is one solution, one possible solution for these kinds of monitoring tasks. And I don't know exactly which service you are referring to, but with the Sentinel, especially in the Netherlands, where there is a relatively large overlap between the different passes, there is a recurrence time of the repetition time of a satellite image in the range of 2 days, 3 days, from Sentinel-2A and Sentinel-2B, so from different satellites. There are even satellite systems which count on this, and there are more satellites for these kinds of purposes. So I don't know exactly the service that you are mentioning, but still in the Netherlands, cloud cover is a challenge. So these things can be better done with radar, and that logic is the same. So let's not go too deep in it. I don't want to deviate from Andreas.
Yes, so we're looking at downtown Budapest right now. This is the landscape, the chain bridge, and you can see the characteristic shadow. You can see a couple of ships, but what I want to raise your attention to is this part here. So we are in the shadow of a mountain, Galiaspil, and this shadow has been corrected. It's sort of brighter than its surroundings, right? This is part of what happens during Sentinel to level 2 processing. The image is radiometrically corrected. The effect of topography is equalized out as far as possible. So if you go back to the other collection, Sentinel to level 1C, which is closer to the raw image, then what you see is the colors are going to be less bright. because the atmosphere has much more effect. But for example, these shadow artifacts or shadow correction artifacts are gone. If you click it on your side, yes. So it's a lot hazier, right? It's not as crisp, but this part is in shadow. It's black. We can move over to these different visualization layers. This is a false color near infrared image. So you can see the bands down here, right? So true colors is bands 4, 3, and 2 in red, green, and blue. And near infrared false color is taking band 8 instead of the red band, and band 4 instead of the green band. So green vegetation is going to be red. Why does this make sense? Well, because vegetation reflects much stronger in the infrared than it does in visible light. So coming back to Budapest and near infrared imagery. So this gives us a lot better signal to noise ratio. It also makes it easier to identify vegetation in places where it's not so easy to see. So you can see all these green spaces along parks and inside courtyards with the near infrared false color image. We don't have that much time left to go into much detail, but we will do this later. But before that, I want to draw your attention to themes and highlights. So this is the configuration panel. And right here, we have a collection of exciting images for various applications. So if you select one of these that you're interested in, I'm going for geology, then you get these individual highlights, individual places that you can click on, and the browser is taking you to that place, and you get a small explanation. So this is the easiest way to just explore the functionality of Copernicus Browser and the things that you can do with satellite imagery. Just click through our highlights, browse around, take a look, and you will see some amazing things, I hope. You go here, configurations. So this is the calendar panel, right? You close that, and just below that, you have the configuration panel. And then in the configurations, you select one of the themes. And then that theme is going to give you a collection of highlights. Okay, these are some individual places to explore. And then to test the time-lapse functionality, I think it's best to go to a place with intensive agriculture, because there we can see stuff happening across large areas. This link I have is, I think, just southwest of Gödöllőr. It helps you find the place once it's opened up on my side. Yes. Oh no, it's not Gödöllőr. It's southwest of Budapest. So it's a place called Martonvásár, intensive agriculture in this area. If you just put it in the search bar here, then it's going to navigate you to the place. We are still using the same satellite image from the 9th of November. Okay. I can zoom out a little bit so that you see where we are. And so the tool I want to show you is the time-lapse tool. If you click on this little film icon, which says create time-lapse animation, and then you click the play button, you can set the time frame of the time-lapse, so the start and the end. I'm going to look for 1 year. So we select the year of 2023, and it's going to load the image selection in a moment. You have to select an image, right? So from the 3rd of November 2023 to the 9th of November 2024, we are going to have the option to apply cloud filters in a moment. Yes, we only want images that are completely covering the study area. We accept cloud coverage of maybe only 20%. And now we click search. And as I speak, the server is carrying out an API request, right? A catalog API request, first of all. It's querying a list of images that fulfill these criteria, 30% cloud cover and covering this study rectangle. And then it's carrying out a process API request, creating an RGB visualization of this image according to the same visualization which we had in the browser. And then this is going to be effectively the system that creates the animation. You can, if the list has appeared on your side, you can scroll into it you can look at the individual images one by one. If you find something is very cloudy or you don't want it for some other reason, you can also just tick it out. And then once you have this list, oh yes, here we go. So December 2023, January 2024. Some images are slightly hazy, but most of them are clear. May, June. I'm picking this image out, it's cloudy. July, August, September, October, and November, right? So now we can play this GIF. And so this is what you see. You see the agricultural activities as they happen, the dark brown of freshly plowed bare soil, the yellow of rapeseed flowering, the sort of yellowish brown of crops growing into senescence before being harvested. So this little time lapse is a very, very clear tool for interpreting things that are happening across large areas. Often a single image will not give you an understanding of what you see, but if you create a time lapse, then you will have an understanding of the process that's actually going on. So this is what the time lapse tool is used for. This is how it works. And if you just click download here, which I'm not going to do, then it's giving you a GIF format image, which you can then embed in a website or send in an email or share on your social media. Okay, and now we'll move over to NDVI. I'm clicking the custom script away. So if you just click on the NDVI visualization, you will see everything is green. We have applied a green palette to everything that has a positive NDVI. This is just the tool you use. And then we select an area of interest. I'm going to identify one of the parcels. Let's take this one here in the center. I'm drawing an outline around it. Okay. And now this little histogram icon on this other time series icon is becoming active. First of all, let's look at the histogram. So on this specific satellite image, we are now running a statistics API request within this area of interest. And for these pixels, we want to look at the distribution. And what we see is we have a lot of pixels of very high NDVI and some pixels of low NDVI within this area. So this is the histogram. This is the spectral profile. So these are the Sentinel-2 bands, right? We can start with the values actually. So for band 1, this is our value. For band 12, it's this number. These are the individual me values of the spectral bands within this set of pixels, and we can map them to a chart. So this is the near-infrared reflectance maximum of chlorophyll. These are the red, green, blue bands that we use for creating true color. And this pattern here is what we call the red edge. So the shape of this curve is going to indicate the condition of our vegetation. And you see that we have these two red edge bands here, these three red edge bands here, which we use to infer the condition of vegetation. We have a reference spectrum here. This is what grass looks like. So our area is quite similar to grass in November. This is what water looks like. That's absolutely different. So this is definitely not water, right? This is how you use the spectral explorer. And then comes the magic. This is the statistical info chart. So again, now we're running a statistical API request, not just on this image, but on the time series of image from the last month. And again, we can filter the clouds away. We leave out the images which have cloud cover above 23%. And now we want a time series for a whole year. And in the background, you see the servers crunching all these images, querying them without opening them and loading them on my screen, just looking at the NDVI values of this area of interest in those pixels. And so what you see is a typical time series curve, vegetation growing up in spring, being harvested in autumn, and then being replanted in early autumn. This could probably be something like corn or sunflower in this vegetation season, and then we have a second plantation of either a cover crop or maybe even autumn or winter cereals. So this is how you use the time series tool. This is how you perform very basic API queries in Copernicus Browser. Oh yeah, and now just as a bit of an intro or teaser to the fieldwalk, let me load an image of our place, and then we can move forward with questions. Any questions?
You using the NDVI, so can you get like on the same map, we'll be able to compare the NDVI like database between 10 years?
10 years is difficult because we only have Sentinel-2 data since 2016. So you would have to use a different sensor. And at the moment, Landsat is not in the browser yet.
Let's say 2017 to
2017, yes.
2000.
Yes. The way you do that is this little button, adds to, and then you can add to compare. Okay. Now we change the time. We go back all the way to 2016 November. We have a cloud-free image, so we're lucky. And then we add this to compare as well. And now if you click on these two arrows, you are moving over to compare mode. These are the two images you are comparing, right? And then there's two ways to compare. Either you split and the right side of the screen is one image and the left side is the other. Like this. Or you can also do it with transparency.
Can you get the data, or it's just a picture? Yes.
No, you can also get the data. So you can download the data using the download tool. This would allow you to, if you go to analytical, okay. No, we have to step out of the compare mode. But just one quick thing I want to show in the compare mode is that it's possible to share compares as well. So you can generate the URL, which will take somebody straight to the compare, and then you can show them a before-after thing, even if they've never seen a satellite image before. Going back to regular mode. Download, analytical, and then here is NDVI. It's going to give you an image of NDVI. And the image format could be 32-bit float for a TIFF, and then that's actually the numbers. This is how I would do it. This is the place we are at, Gedulde. That's the university. Again, the share link is incorrect, so I'm posting a new one in the chat. Okay, questions. Where I click for time lapse, that's easy. I click here on the little film icon. Is there a way to check the API request that was generated? Not the API request, but the important part of the API request, the evalscript, that can be checked, yes. So if we are looking at TrueColor, if you just click on this little code icon, then it's opening up a script window, which will actually show you the code that was done for the visualization. So at the moment, we are selecting these bands for input, red, green, blue, and data mask, so whether the data is valid. We have a 4-band output, which is again RGB and transparency. We are applying the small contrast enhancements, and then we are applying this evaluate pixel function and returning the RGB. And again, a bit more contrast and saturation enhancement, and then out comes the image. So within the API request, this is the part that describes what's actually happening with the data. It's also possible to create an API request with this specific code. We're going to do it actually the day after tomorrow, but I can give you a quick glimpse. shapps.dataspace.copernicus.eu/requests builder. So this is where this is a graphical interface to an API request. You can select the data collection. You can select the output format, the image format, the area of interest. This is where you put the eval script, so the visualization script. And if you run this, then this is the request preview. So this is the actual code that the API request is performing. You can also do the same thing for statistical API over here. So this is where you would experiment with API requests or preview them if you're not sure about the code. It's also possible to create a request, which you then copy and paste in your code on your side. Replicating the time series request in API. Yes, it works with the Sentinel Hub APIs. It's a process API request. You would have to individually create the time identifiers and then the output resolution. One thing we can do is I can copy the area of interest. So we still have the area of interest. I can just copy it, and I can put it in Request Builder over here. And this should work. Yes, so this is the first step to doing the same request. I can also copy the custom script, the evalscript, over here. I can set the time frame at the moment to the 9th of November. Should be okay, yes. So this is just a request for one single image. But this is how you would approach creating a time lapse through the request builder. Let's move on to the other questions. How can you determine the NDVI threshold for a certain study area from the histogram? Well, it depends on what you want to do with the NDVI threshold, right? If you want to separate one kind of vegetation from another, then what you would do is generate an area of interest for that kind of vegetation, and then another one for another kind, and compare the histograms. If you want to do this live, let me go back for a moment. I'm hiding the layer first. Not much worse in this area. And yeah, somewhere down here, sure. So this is the NDVI histogram for my crop field. I hope it's faster on your side. Yes. Okay, so the NDVI is somewhere between 0.12 and 0.25. We are on the 2016 image, I think. And now I'm deleting this area of interest. I'm creating a new one over on this sort of floodplain forest between the river and the oil refinery. And I'm rerunning the histogram thing.
Where was this the cloud coverage?
It's in the date bar. See, we have the forest now, which runs sort of between 0.40 and 0.80. So if you want to separate forest from crops, then you would go for somewhere around 0.40, and you would have a pretty nice separation in the histogram. I'm showing you the cloud slider in a moment. In the calendar panel, you have the cloud slider here. And if you want to generate a time lapse, there's also a filter for cloud cover